In a previous tutorial, we examined how to use RailClone to create a single parametric building. In this tutorial, we're going to up the scale and share techniques to quickly create entire cities. Starting with a simple grid, we'll demonstrate how to populate a city with 3 types of building, each showcasing a different technique. We'll start with courtyard buildings, then add towers that are automatically scaled and oriented to fill the entire city block, and finally fill blocks with multiple mid-sized commercial buildings. All of these techniques use RailClone, a procedural modelling tool from ITOOSOFT. In addition to useful layout tools, RailClone is able to render enormous polygon counts, making it well suited for this kind of task. Don't worry though if you don't have RailClone, you can use the free version downloadable from ITOOSOFT's website. This light edition will limit you to 3 source building models per RailClone object, but apart from that, all the other techniques shown in this tutorial will work just fine. So get started by laying out the city using 3ds Max's built-in tools to create a closed spline for each city block. When designing the city, there are a couple of things to consider. Firstly, the techniques in this tutorial work best with rectilinear city blocks. Secondly, vertex type should be set to corner for 90-degree bends. These will be used by RailClone to add corner geometry, but they're also useful to add zebra crossings and other details at the intersection of the streets. Thirdly, for gradual changes in direction, use Bezier or smooth vertex types, but be aware that we won't be deforming geometry in this tutorial, so there's a limit on how curved splines can be before adjacent segments intersect. Once your city's created, it's a good idea to create a smaller collection of splines you can use to test out your procedural styles. This will speed up the creation process because Forest Pack and RailClone won't need to perform complex calculations on the entire city grid. So create a couple of rectangles and maybe a straight spline or 2 and attach them so that they're a single object. Next, merge your chosen assets into this scene. In this example, we'll use the free sample from Evermotion's AM172 collection of house models. So RailClone doesn't automatically consolidate materials and reassign IDs like Forest Pack, so you're going to need to create a single multi-sub-object material that can be applied to all of the source geometry. To make this clear, the same single material needs to be applied and work correctly on both the RailClone objects and all of the individual components. An easy way to consolidate materials is to attach the objects together into a single mesh. By doing this, Max creates a multi-sub-object material and reassigns IDs automatically. Then all you need to do is detach each object back into a separate item and then center and readjust the pivots if necessary. So once that's done, we're ready to create the first of the 3 types of RailClone object. This one will add buildings around the perimeter of a city block and is particularly suited for courtyard, townhouse and terrace style architecture. So create a new RailClone object and open the style editor. Create an L1S generator and wire a new spline node to the generator's spline input. Use the spline node to select the test spline we created in step 2. Create a new segment node and disable slice and bend to make sure that full instancing is retained. To add all the buildings to the RailClone graph, right-click on the existing segment node and select Clone Multiple. Select the building object and click OK. Each building will be automatically loaded into a brand new segment, each with the same settings as the original. Wire these segments to a new randomized node, and then wire the randomized node to the generator's default input. The buildings appear and they're centered on the spline. To change this, wire a transform node between the random node and the generator, and then use it to change the Y alignment to bottom. Wire an empty segment to the corner input and set the generator's bevel mode to none. You'll notice when you're using high poly source geometry, RailClone displays the object as simple boxes to keep the viewports fast and interactive. You can also choose to display the geometry as a points cloud. These settings can be edited in the display rollout. The way that RailClone distributes segments to fit along the spline can be controlled using the default options found in the generator's Rules tab. In tile mode, the segments are simply placed one after another along the spline, and the final segment is sliced to fit. Although because we've disabled slicing, the final segment will actually extend beyond the edge of the spline, which is going to cause problems with buildings extending outside the block and crossing the pavements and potentially into the roads. So there are 3 other default modes available. Adaptive, which subtly scales all of the segments by the same value so that they fit into the spline exactly. Scale, which stretches a single segment the length of the spline section. And finally count, which allows you to specify a fixed number of segments and then scales them all equally to fit the available space. Unfortunately, these modes all require the segments to be exactly the same length on the x-axis, which is not the case and is not likely to be the case with our buildings. So none of these existing modes are appropriate. Luckily, you can add others using the built-in macros. So set the mode back to tile, and then add a scale final x segment macro from the transforms group. Wire it between the transform node and the generator. This macro will scale the final segment before a corner or at the end of the array to fit the available space. The minimum last object size parameter is used to determine the minimum size of the final building. If you increase this value, you'll get larger final buildings, and if you lower it, you'll get small, thin buildings. Because the position of the building following the corner does not take into consideration the depth of the building preceding the corner, there are overlapping segments. To fix the problem, we need to add random buildings to the corners in such a way though that we can reliably predict their size. The randomized node won't work for this, but instead you can wire the existing buildings to a new selector node. Then export the index and wire it to a random number generator. Set the minimum value to 1 and the maximum to the number of buildings attached, 4 in this case, and set generate on to X spline section. Then wire a transform node between the random node and the generator, and use it to change the Y alignment to bottom. Now we need to control how buildings are arranged at the corner. We want a single building to appear entirely before the corner vertex, with an empty segment following the corner the same size as the Y dimension of the preceding building. To do this, we wire a compose operator to the corner. Wire the transform node to the first input. Wire an empty segment to the second input. Then wire it again to the third input, but this time via a transform operator that we'll be able to use to control its X size. Export the X fixed size of the transform node and be sure to enable it in the parameters. Export the Y size attribute from the selector operator and wire this to the X fixed size input of the transform node. The Y size of the randomly selected corner segment now controls a gap that follows the corner. To finish the effect, wire the selector operator's output to the end segment input of the scale final X segment macro. This will allow the macro to take into account the size of the corner segment when it calculates the size for the final segment. For all the styles in this tutorial, we will add the ability to use the material ID assigned to a spline section to control whether or not it generates geometry. To do this, right-click on the generator and export limit by ID and limit material ID. Wire a new numeric node to each of these inputs and change the type of the first to Boolean and the second to integer. Using the parameters rollout, you are now able to control whether the limit by ID function is enabled or disabled and choose which ID value generates geometry. This style is now built. If you want to create more variety in your city render, you can now duplicate this RailClone object and simply swap the geometry referenced in the segment nodes to create different architectural styles for each block. Give each RailClone object a different material ID so that you can easily manage how they're distributed on the city grid. In our sample render, we had 20 different courtyard styles, each with its own corresponding material ID. In the next section of the tutorial, we'll add skyscrapers that rotate and scale to fill an entire city block. So, After preparing the source geometry, just like we discussed earlier, so that all assets share the same multi-sub-object materials, create a new RailClone object and open the style editor. Create a 2D array and then add a new spline node and wire it to the clipping spline input. Pick a spline from the scene. In the generator settings, enable extend XY size to area so that the size of the array is automatically calculated to fit the size of the base spline. Change for no slice to preserve, and then add the buildings by adding a new segment, disabling bend and slice, and using the add multiple option to import all of the tower buildings. Once that's done, wire all of the building segments to a new randomized node and wire the randomized node to the default input. The building will be tiled inside the spline area. We want exactly one building per spline area. We could use the generator's default scale mode, but this only works for the x-axis. Instead, we'll use a macro that allows you to scale on both axes. Wire a scale to array macro between the random node and the generator and enable scale to array X and Y. This is all working well, but next we want to rotate the building to match the orientation of the spline. By default, the array's rotation will match that of the RailClone object. We want each array to rotate to match its subspline instead. To do this, open the generator settings and change auto align mode from none to spline. This mode calculates a direction vector based on the first and second vertices in a closed spline, and it uses it to align the array. While you're here, you should also change hierarchy checking to none to drastically speed up calculation times. And finally, export the limit by material ID and limit by IT values and wire them to numeric nodes. The third technique combines the previous two. We will automatically calculate the size and the orientation of the array, but then scale the final segments on the X and the Y axis so that multiple buildings can fit neatly inside a city grid. To do this, create a new RailClone object and open the style editor. Add an ITOOSOFT generator and turn on extend XY size to area. Set auto align to spline and set hierarchy checking to none. Attach a spline node and pick the spline from the scene. Create a segment and disable bend and slice. Use add multiple to import the buildings just like we did in the previous exercises. Wire all of the building segments to a new randomized node. Wire the randomized node to a transform node and add some padding so that there's a gap between the buildings. To ensure the buildings fit inside the spline, we'll scale the final building on the X and Y axis by adding two macros. Wire a scale final X segment and scale final Y segment macro in series between the transform node and the generator's default input. These are the same macros we used for the courtyard blocks earlier. Increase the minimum last object size parameter until you remove any ultra thin buildings. And then to finish the style, once again we'll export the limit by material ID and limit by ID values and wire them to numeric nodes. Set the material ID value to 22. So we now have 20 courtyard building variations on material IDs 1 to 20. We've got our skyscrapers on material ID 21, and finally these offices and commercial buildings on material IDs 22. Using these numbers, you can change the material IDs on your city grid to design the layout of your city. Alternatively, for the demo scene, we used a script included in the downloads to randomize the material IDs. To assign all our objects to the city grid spline, instead of doing them manually, you can also assign multiple RailClone objects using a simple code snippet. So in this case, you would select all of the RailClone objects, open the MacScript listener by pressing F11, and type for obj in selection, do obj.banode, open brackets, 1, close brackets, equals, $, and then the name of the spline that you want to assign to the RailClone objects. In that way, you can very quickly assign one spline to multiple RailClone objects. So once you're happy with the layout of your city, save the file and create a new max scene. We're going to xref the buildings into this scene so that we can continue to add details without having to wait for long save times. Once it's loaded up, clone the city spline and extrude it to create a base for the buildings. Then add a plane the size of the whole city. Translate the plane down on the z-axis, the height of a pavement, to create the roads. The city grid spline can also now be used to add cars to these streets. Note that here, instead of modelling and texturing roads, you can use a simple plane to cover the entire area, and then we've used a V-Ray distance texture to parametrically add wear and tear based on the distance of the surface from the city block. There's not time in this tutorial to go into that technique, but the material is included in the downloads so you can have a look and see how it was done. Either RailClone or Forest Pack could have been used to add cars, but for this example, since we already have a tutorial for Forest Pack, we'll use RailClone. Don't forget though that your car models will need to be prepared so that they share a single multi-sub-object material, and none of the geometry should be grouped. So once you're sure about that, create a new RailClone object and add car models to the graph in the same way as you did for the buildings. Now wire these to a randomize operator and add a transform node to rotate the cars and add some translation variation if necessary. Now if you wire the transform node to the default input, the cars will be bumper to bumper. To add some spaces, add a new sequence operator after the existing transform node and then wire a brand new transform node to the second input. Wire a null segment to the new transform node. Export its X fixed size property and enable it from the parameters. Wire a random number node to the X fixed size input and adjust the minimum and the maximum values to control the spacing. To make this style easier to edit from the Modify panel, let's export a few parameters. From the random number node, export the minimum and the maximum values and attach new numeric nodes set to scene units. From the generator, export fillet radius, Y offset and Z offset. Wire new numeric nodes to these two, and set them all to scene units. Once you're done, you can apply the style to the city grid and easily adjust the parameters to position the cars and control the density from the Modify panel. And if you want multiple lanes of traffic, simply duplicate this object and edit the Y offset value. There are several other RailClone objects in the final scene. Most of these are very simple and they've been included in the exercise files so that you can see how they've been created. For example, we used RailClone to add the pavements, the street lights, road markings, pedestrian crossings, and even people walking along the pavements. To make things easy to set up, all of these are driven by the same set of city grid splines used to generate all of the buildings. So let's take this even further and use the same splines again to add trees to our city. We'll use Forest Pack to add trees to the streets. So create a new forest object by dragging an icon in the viewports. Open the Modify panel, go to the distribution rollout and change the mode to path. Add the city grid to the splines list and use the spacing property to control the distance between trees. In the geometry rollout, add a tree from the library. And if it's too large, you can resize it using the scale property. Back in the distribution rollout, use the Y offset value to move the trees to the edges of the pavement. So that's looking good, but the courtyards now look too empty. So let's add some trees to them too. Clone the city grid and delete the subsplines that create the towers and commercial buildings. Create a new Forest Pack object and add the spline to the areas list. In the geometry rollout, add one or more trees from the library and then go to the distribution rollout. Select a pattern and adjust the density. For both Forest Pack objects, you should also enable rotation and scale randomization, and also turn on limit to visibility and auto assign to active view from the camera rollout to optimize the scene by removing items that aren't visible in the final render. Finally, to remove the trees from the edges of the city block where they intersect with the buildings, go to the Areas rollout and enable Density Fall-Off. Edit the fall-off graph so that it's stepped to create a hard cutoff instead of a gradual reduction in density. You can then increase the include value to remove trees from the perimeter of the city blocks. To reduce the size of the trees, you can use the scale fall-off settings too. This time though, don't set the minimum scale to 0 in the fall-off graph. 30 to 40% will look much more realistic. So using these tricks and techniques, we've been able to generate hundreds of buildings, thousands of trees, streets full of cars and people, many more small details to create a convincing 3D render. Best of all though, once you've set this up, you don't need to do it again, and you can easily create cities for other projects by simply changing the base spline. And you could even extend this by adding more RailClone items to the streets to create street clutter such as road signs, traffic lights, bus shelters, bins, advertising hoarding, and much, much more.